Now, the depth first search can be used for a lot of things. One of the things we can do is, as I said, add start and finish times. If we decide to record when we discovered an edge, or when we first visited it, and then when we would have left it if we're backtracking through it. Remember, the whole depth first search process involves starting at the node, going as deep into the graph as we can, and then tracing back our steps to the starting point. Right? Now, if every time we find a node, we plant a flag and say, yes, we found it, and every time we're leaving the node, we plant another flag, and we record those times, then we can actually get some useful properties of the graph. Now, if we're going to leave the start and finish times on this graph, we'd say that we'd have visited node A at time unit 1, this is node B at time unit 2, F at 3, D at 4, E at 5, G at 6, H at 7, and C at 8. Now, once we're backtracking, we're then going to make a note of when we left the node. So we'd have left this node at time unit 9, left this node at time unit 10, 11, 12, 13, 14, 15, and I've left planted our flag saying we're going to leave or finish visiting from A at time unit 16. Now,
Excuse me. F is wrong. That's not 14.
oh, thanks. Thank you. Now, there are some mathematical comparisons that can be done to tell which one of these edges in the graph fall into one of a set of classes. I won't go into the mathematical comparisons, but I'm going to give you a shortcut. The mathematical comparisons are in your book. We don't have time to go through them right now. But once we've done the depth first search, then all the edges that are on the depth first search tree are classified as tree edges. Now, if you, by the way, these are normally, the edge classification is normally done on a directed graph, but this is not directed, and I still use it to illustrate. Now, there are 4 types of edges. You have your tree edges, you have your forward edges, you have your back edges, and then you have your cross edges. Your forward edges would be those edges that have some ancestor-descendant relationship in the depth first search tree, and you would have moved forward. The forward edge would carry forward into the tree. Alright, to illustrate, I think I need to put some arrows on this graph. Okay, let's say that's arrow here. We can't, the edges that we have identified as a part of the DFS tree, I'm going to make sure that those edges are pointing in the direction that the DFS tree did. The rest of the edges, I'm going to take free rein in assigning directions. Alright, now from A to D, these are all directed. E to A here. Now, if I had superimposed some of these other edges on the graph, and I found out that between two nodes, I have ancestor-descendant relationship in the depth first search tree. For example, let's say I take the edge from F to G. Now, the edge from F to G would carry me forward into the tree. And there is a relationship from ancestor to descendant. So I'd call this a forward edge. So this would be a forward edge. Remember, all those edges that are marked with green, those are tree edges. Edges that would be a shortcut forward in the tree would be forward edges. The edges that would carry us back up the tree, let's say from the edge from E to A, that would be a back edge. And the edges that are not a part of the edges that don't have an ancestor-descendant relationship at all, those would be cross edges. We do not have any cross edges in this graph. Simply because of how the graph is, it's just one line. But let's say your depth first tree had looked like this, and there's an edge from C to F, then that would have been a cross edge. Alright, moving on.
And the tree one, sir?
There?
What you said tree one was again?
Which?
The tree edge.
Oh, the tree edges are the edges that are on the depth first or tree.
Okay.
So once you've done the DFS tree and you found out that you have that set of edges, you have a set of tree edges. The edges that will carry you forward in the tree, and if of course there's an ancestor-descendant relation between the nodes, then that would be a forward edge. If you have an edge that will carry back up, that's a back edge. If an edge that would pretty much jump across the tree, that's a cross edge. And that's a shortcut qualitative description. There's a more mathematical proof for those terms, which we won't go into right now. Alright, is that the final? Are there any more questions on this tutorial? No, baseline classification determine whether or not there are any cycles. If you have back edges, you have cycles. Because the tree edge will carry you forward and the back edge will carry you back. So you would end up having cycles in the graph. Cycles in a graph mean that there are certain applications you wouldn't want to use that graph for. I could end up with an infinite process. Alright. Last tutorial 9, we're just going to discuss it. We actually don't have any questions on this, but I just want to give a brief discussion of some terms